Global wind patterns. Hello and good day, everyone. I am Remer Didili Iras, a graduate of General Academic Strand in Sorsogon National High School, Senior High School. I am here to discuss the global wind patterns and its type, as well as an inclusion. I also include the subtopics to which are highly related to the major topic. What is global wind patterns? Global winds blow in belts encircling the planet. The global wind belts are enormous and the winds are relatively steady. These winds are the result of the air movement at the bottom of the major atmospheric circulation cells, where the air moves horizontally from high to low pressure. Technology today allows anyone to see global wind patterns in real time, such as Earth wind map. On the picture provided on the next slide, it shows the global wind belts that is present in the North Hemisphere and where it is measured in degrees. Let's proceed to the first major atmospheric circulation cells, the Hadley cell circulation. In the Hadley cell, air should move from north to south, but it is deflected to the right by the Coriolis. So instead of the air blows from north to south, it blows from the northeast to the southwest. This belt is the so-called trade winds because during that time of sailing, ships were good for trade. So what has something to do with this Coriolis as mentioned in the first major atmospheric air circulation? So the term Coriolis is named after the French mathematician and physicist Gaspard Gustave de Coriolis. Coriolis is an effect whereby a mass moving in a rotating system experiences a force, or the so-called Coriolis force, acting perpendicular to the direction of motion and to the axis of rotation. The second atmospheric circulation cell is the Ferrel cell. In Ferrel cell, air should move south to north, but the winds actually blow from southwest. This belt is the so-called westerly winds or westerlies. So looking at the picture, the Ferrel cell is located between the two air circulation, to which are the polar cell and the Hadley cell. Finally, the last atmospheric circulation cell is the polar cell. The polar cell, the winds travel from the northeast and are called the polar easterlies. The wind belts are named for the direction from which the winds come. So let's state, for example, the westerly winds. It blows from west to east. These names hold for the winds in the wind belts of the southern hemisphere as well. Let's take into account the similarities of these three major atmospheric circulation cells. So all of these are mostly and tremendously affected by the Coriolis effect, wherein we have discussed on the first atmospheric circulation cell, which is from the Hadley cell down to the last, which is the polar cell. Global winds and precipitation. The high and low pressure areas created by the 6 atmospheric circulation cells determine in a general way the amount of precipitation a region receives. In low pressure regions, where air is rising, rain is common. In high pressure areas, the sinking air causes evaporation and the region is usually dry. Now let's proceed to the polar front and jet streams. The polar front is the junction between the Ferrel and polar cells. At this low pressure zone, relatively warm, moist air of the Ferrel cells runs into relatively cold and the dry air of the polar cell. The weather where these two meet is extremely variable, typical much of North America and Europe. So the polar jet stream is found high up in the atmosphere where the two cells come together. A jet stream is a fast-flowing river of air at the boundary between the troposphere and the stratosphere. Jet streams form where there is a large temperature difference between two air masses. Let's take a look at the picture and difference of the polar front and the polar jet stream. On the image, it depicts on why the polar jet stream is considered as the world's most powerful, for it moves seasonally just as the angle of the sun in the sky migrates from north and south. Polar jet stream is also known as the jet stream that moves south in the winter and north in the summer. Atmospheric pressure and winds. A few basic principles go a long way toward explaining how and why the air moves. Warm air rising creates a low pressure zone at the ground. Air from the surrounding area is sucked into the space left by the rising air. Air flows horizontally at the top of the troposphere. The horizontal flow is called advection. The air cools until it descends. Where it reaches the ground, it creates a high pressure zone. Air flowing from areas of high pressure to low pressure creates winds. Warm air can hold more moisture than cold air. Air moving at the bases of the three major convection cells in each hemisphere, north and south of the equator, creates the global wind belts. Within the troposphere are convection cells. Air that moves horizontally between high and low pressure zones makes wind. The greater the pressure difference between the pressure zones, the faster the wind flow. Convection in the atmosphere creates the planet's weather. When warm air rises and cools in a low pressure zone, it may not be able to hold all the waters it contains as vapor. Some water vapor may condense to form clouds or precipitation. When cool air descends, it warms. Since it can then hold more moisture, the descending air will evaporate water on the ground. Air moving between large high and low pressure systems creates the global wind belts that profoundly affect the regional climate. Smaller pressure systems create localized winds that affect the weather and the climate of a local area. Local winds. Local winds result from air moving between small low and high pressure systems. High and low pressure cells are created by a variety of conditions. Some local winds have very important effects on the weather and climate of some regions. Let's discuss the land and sea breezes. Since water has a very high specific heat, it maintains its temperature as well. So water heats and cools more slowly than land. If there is a large temperature difference between the surface of the sea or a large lake and the land next to it, high and low pressure region forms. This creates the local winds. Land breezes. It blows from the land to the sea in the water. Some warmer air from the ocean rises and then sinks on land, causing the temperature over the land to become warmer. Sea breezes. It blows from the cooler ocean over the warmer land in summer. Sea breezes blow at about 10 to 20 km or 6 to 12 miles per hour and lower air temperature much as 5 to 10 degrees Celsius or 9 to 18 degrees Fahrenheit. So the land and sea breezes create the pleasant climate for which the Southern California is known for. The effect of land and sea breezes are felt only about 50 to 100 km or 30 to 60 miles inland. The same cooling and warming effect occurs to a smaller degree during the day and night. Let's state that the principle that land warms and cools faster than the ocean. Monsoonal winds. Monsoon winds are larger-scale versions of land and sea breezes. They blow from the sea onto the land in summer and from the land onto the sea in winter. Monsoon winds occur where very hot summer lands are next to the sea. Thunderstorms are very common during monsoons. The most important monsoon in the world occurs each year over the Indian subcontinent, wherein more than 2 billion residents of India and Southeastern Asia depend on monsoon rains for their drinking and irrigation water. Back in the days of the sailing ships, trades in goods, seasonal shifts in the monsoon winds carried goods back and forth between India and Africa. In the Philippine context, The Philippine Atmospheric, Geophysical, Astronomical, and Space Administration defined two types of monsoon winds present in our country. The southwest monsoon or the habagat. During this hanging habagat, the high pressure area is at the Australian continent and the low pressure area is at North China, Mongolia, and Siberia. The gusty winds from the west and excessive rainfall often turn into dangerous typhoons. Rain aids farmers to irrigate the rice fields. Thus, heavy rainfalls triggers floods and partially endangers residents living near riverbanks. Typhoons made by habagat unfortunately cause millions and sometimes billions worth of reconstructions, damages including in the infra, and will kill hundreds of Filipinos. The next one is the southwest monsoon or the hanging amihan. It affects the country between late June to October. Occurrence may vary each year. Low season in the Philippines occurs during the habagat season because of frequent rainfall and high humidity. A season of rain, floods, and landslides are regular incidents this season. Mountain and valley breezes. Temperature differences between mountains and valleys create the mountain and valley breezes. During the day, air on mountain slopes is heated more than air at the same elevation over an adjacent valley. As the day progresses, warm air rises and draws the cool air up from the valley, creating a valley breeze. At the night, the mountain slopes cool more quickly than the nearby valley, which causes a mountain breeze to flow downhill. Katabatic winds. The katabatic winds move up and down slopes, but they are stronger mountain and valley breezes. Katabatic winds form over a highland area like a high plateau. The plateau is usually surrounded on almost all sides by mountains. In winter, the plateau grows cold. The air above the plateau grows cold and sinks down from the plateau through gaps in the mountains. Wind speeds depends on the difference in air pressure over the plateau and over the surroundings. Katabatic winds form over many continental areas, in which extremely cold katabatic winds blow over Antarctica and Greenland. The next one is the Chinook winds. Chinook winds are also called as the Foehn winds. Develop when air is forced up over a mountain range. This takes place, for example, when the westerly winds bring air from the Pacific Ocean over the Sierra Nevada mountains in California. As the relatively warm, moist air rises over the windward side of the mountains, it cools and contracts. If the air is humid, it may form clouds and drops rain or snow. When the air sinks on the leeward side of the mountains, it forms a high-pressure zone. The windward side of a mountain range is the side that receives the wind, and the leeward side is the side where the air sinks. The descending air warms and creates strong, dry winds. Chinook winds can raise temperature more than 20 degrees Celsius or 30 degrees Fahrenheit in an hour, and they rapidly decrease humidity. Snow on the leeward side of the mountain disappears, melts quickly. If precipitation falls as the air rises over the mountains, the air will be dry as it sinks on the leeward side. This dry, sinking air causes a rain-shadow effect, which creates many of the world's deserts. Santa Ana winds. Santa Ana winds are created in the late fall and winter when the Great Basin east of the Sierra Nevada cools, creating a high-pressure zone. The high pressure forces winds downhill and in a clockwise direction because of the Coriolis effect. The air pressure rises, so temperature rises and the humidity falls. The winds blow across the southwestern deserts and then race downhill and westward toward the ocean. Air is forced through canyons cutting the San Gabriel and San Bernardino mountains. The Santa Ana winds often arrive at the end of California's long summer drought season. The hot, dry winds dry out the landscape even more. Therefore, if a fire starts, it can spread quickly, causing a large-scale devastation. High summer temperature and the desert create high winds, which are often associated with monsoon storms. Desert winds pick up dust because there is not as much vegetation to hold down the dirt and the sand. A A habuob forms in the down routes of the front of a thunderstorm. The image next to the left is a habuob. Dust devils. Dust devils are also called whirlwinds, form as the ground becomes so hot that the air above it heats and rises. Air flows into the low pressure and begins to spin. Dust devils are small and short-lived, but they may cause too much damage, including in infrastructures, buildings, architectures, and mostly it may kill lives. That is the end of my discussion, and thank you for watching my video lecture. For further clarifications, questions, and queries, you can find me at my personal Facebook account, Raymark Daloiras, or email me at daloirasraymark08@gmail.com. Thank you very much and have a good day.